This is All India Radio. Radioscope, the National Science Magazine program.
Good evening to all our dear listeners and a very warm welcome to the April edition of National Science Magazine Radioscope. Nothing in nature is to be feared. It has to be understood. Science happens to be the evidence-based study to understand the nature of things and dispel fear. With that premise, Radioscope during the next 30 minutes takes you all on a journey of scientific understanding of nature, unfurling a few scientific and technological advances in the fields of astrophysics, nanotechnology, wildlife, medicine, and artificial intelligence. The curiosity of mankind about the planets, stars, galaxies, universe, or multiverse has opened up newer and better understanding of the cosmos. Indian astrophysicists have been at the forefront of contributions to this area of studies. A team of scientists from Raman Research Institute, Bangalore, has recently brought to light the findings on the cosmic dawn. Dr. N. Uday Shankar and Dr. Saurabh Singh are here to elaborate on their findings.
Dear listeners, we are happy to share with you the groundbreaking result from the CMB Distortion Laboratory at the Raman Research Institute, which was published in the prestigious journal Nature Astronomy and was announced on the National Science Day this year. This result pertains to the formation of first stars and galaxies in our universe. First stars lit up the universe when it was only 1/6 of its current age. For reference, astronomers estimate the age of the universe to be 14 billion years. This epoch in the evolution of the universe is referred to as cosmic dawn. Presently, no telescope has been able to detect faint signals coming from the cosmic dawn era, and this has left a gap in the understanding of the history of our universe. Our lab at the Raman Institute has pioneered the development of state-of-the-art radio telescopes to detect faint cosmological signals. Detecting a faint signal from such an early period of the universe is very difficult. Recently, that's about in February 2018, astronomers from MIT and Arizona State University had claimed the discovery of a radio wave signaling from the birth of the very first stars in the universe. They used a telescope called EDGES in Western Australia, located in Murchison Radio Astronomy Observatory. It is one of the quietest locations on the planet to do such an experiment. Our publication in Nature has conclusively refuted the findings of astronomers from MIT and Arizona State University. They modeled the exceptionally bright radiation from our galaxy and were able to recover a possible profile which was claimed as the signal coming from the cosmic dawn. This discovery had created excitement in astronomy community and even beyond. But the strength of the reported signal from cosmic dawn was indeed bizarre when compared to theoretical predictions. The unusual signal, therefore, led to speculation about how the universe may be different from what we understand today by the standard models that we have. However, appreciating that in such difficult measurements, errors in instrument themselves might result in spurious detections, cross-verification of such a claim had become an urgent priority. The world awaited confirmation from independent researchers. Saurabh, will you now tell us in detail how our experiment was conceived and was able to refute the findings of astronomers from Arizona State University and MIT?
The Saras 3 radio telescope, invented and built by astronomers at the Raman Research Institute, has conclusively refuted the claim of discovery of cosmic dawn signal with 95% confidence. The Saras 3 radio telescope is the first telescope worldwide to reach the required sensitivity to cross-verify the claim of Edge's experiment. We find that their detection was a plausible instrumental contamination and not a signal from the depths of space and time. Our results implies that the theories explaining Edge's signal have no observational support. Our findings restore confidence in the current understanding of the evolving universe, re-establishing the prevailing cosmological model of the cosmos. Our efforts to detect these faint signals began a decade back when we designed the first Saras dipole antenna, which stands for Shaped Antenna Measurement of the Background Radio Spectrum. We then refined the design of the telescope to have spherical and disc-cone shapes. Our radio telescopes needed to be deployed in locations with minimal man-made interference. Therefore, we carried out site surveys across India, ranging from our field station in Gauribidnor, organic farms in Timbuktu Collective near Anandpur, near pristine lakes of Ooty, to 4,500-meter high plateaus of Ladakh. Based on our search for man-made interference-free sites, we carried out astronomical observations at Timbuktu Collective. This deployment with a spherical antenna led us to rejecting 10% of the theoretically predicted models of the cosmic dawn. We were the first experiment in the world to constrain physical properties of the very first stars and galaxies using the 21-centimeter signal. It was around the same time that Edge's experiment announced their findings of the cosmic dawn signature. We subsequently shifted our focus to cross-verify their bold claim. Our first attempts by deploying the telescope near Pangong Lake and Indian Astronomical Observatory at 13,000 feet did not lead to the required sensitivity. We attributed this to the confusing radio waves that were emitted from the stratified ground. To solve this problem, we took an innovative approach to antenna design. The antenna, an aluminum cone placed on a styrofoam raft, was floated in middle of a lake to ensure there would be no reflections for more than 100 meters in any horizontal direction. Moreover, the slow speed of light in water reduced the effect of reflections from the lake bottom, and the uniform density of the water made the environment much easier to model. Saras 3 is the first telescope worldwide to observe on water. In an expedition in early 2020, the radio telescope was deployed on lakes in Karnataka, on Dandiganahalli Lake near Chikbalapur and Sharavati backwaters near Shimoga. Analysis from this deployment led us to conclusively rejecting the findings of ASU MIT astronomers. However, the deployment had to be called off abruptly due to the lockdown. The short observation period has prevented us from reaching to deeper sensitivities to uncover the true 21-centimeter signal. Therefore, we are planning more observations on remote lakes in India, especially in the wilderness of Ladakh. Such expeditions will allow us to detect the 21-centimeter signal from the cosmic dawn and unravel this last remaining gap in the history of our universe.
That was Dr. N. Uday Shankar and Dr. Saurabh Singh from Raman Research Institute, Bangalore, speaking about their recent contributions to the field of signals of hydrogen atoms during cosmic dawn. Friends, from the immeasurably expansive cosmos, we now move on to the field of nanotechnology, a branch of science and technology of extremely small things and their applications. Dr. Navakant Bhatt, Professor at the Department of Nanotechnology, Indian Institute of Science, Bangalore, is with us to tell us about the applications of nanotechnology.
Welcome to our program, Dr. Bhatt. As our name itself says, nano means small things. How small is it?
Nano is extremely small. If you want to just define what is nanometer, it's a length scale that we are talking about. It is 1 billionth of a meter, right? So essentially it means that you take a meter and start dissecting it and make 100 crore small pieces of that. And one of that piece is called nanometer, right? And the science and technology at that scale, at that length scale, is called nanoscience and nanotechnology.
What actually is the work being done at the center by you and your students, Dr. Bhatt?
In my group particularly, we are essentially looking at 2 or 3 different aspects of nanotechnology. One of them is to address how can we use nanotechnology for healthcare applications. The second one is to look at application of nanotechnology for environmental application, more specifically pollution monitoring application. And the third one is to really see how we can make these electronic gadgets more powerful in the next 10 years. So we are also working on new nanomaterials.
What are the applications of these sciences? Will you please elaborate it?
This is the work that we have done in my research group, for example. I'm very glad to say we have developed a gadget which is called Anupath. We have this lab on palm which can do 5 blood tests and 3 urine tests, which can be carried anywhere by anybody.
Is it already into the practice?
It's already into the practice. It's already being used. Right now, we are actually setting up a very big manufacturing center, scale up through a startup, which was also incubated at the Indian Institute of Science, and there will be a large scale deployment. This is only such device anywhere in the world which can address diabetes and its management, anemia and malnutrition, early diagnosis of kidney and liver disease.
How far is the industrial application of this science?
As I said, there is a lot of opportunity in both strategic application as well as other applications as well. Is already being used, deployed for use in ISRO, specifically in Sriharikota in their launch vehicle site. They store lot of fuel, gases.
Yeah.
A very small leakage can be hazardous. We have been working with them jointly. At the end of the day, you have to work with all the stakeholders,
Yes.
right? Being in university, you can't be in isolation. This is something that we have been working, and these sensors are now being deployed which can detect very small leakage of these gases.
Thank you very much, Dr. Bhatt. Thank you for being with us.
Thanks a lot. It has been a pleasure.
That was Dr. Navakant Bhatt from Indian Institute of Science speaking on nanotechnology. Dear listeners, our journey now is set to the Annamalai Hills of Tamil Nadu, where Pooja Pawar of National Center for Biological Sciences is working on the life and behavior of one of the most captivating and unique birds, the great Indian hornbill. Pooja narrates her observations.
I have been studying hornbills and their behavior. So we have been conducting this study in the Annamalai Hill Range, which is at the junction of Kerala and Tamil Nadu states. So hornbills are forest specialist birds. They need dense forest, tall trees, because mostly they are canopy birds. They live in canopies, and they have very unique breeding habit. They are monogamous, so they mate for life. I have seen the flock as large as about 50 great hornbills together. Before nesting begins, they have a courtship display. Male is trying to impress the female hornbill. It presents her good, juicy, nice fruits very elegantly, and then she accepts it. The competition happens before the pairs are formed. So when young male hornbills, they attain sexual maturity, then they have a very interesting behavior called cask butting. It's a mid-air activity. So they fly in the air and they lock their beaks. They try and hit each other's casks, and then they spin mid-air, and whoever is the strongest gets the female. Then they separate from the flock in search of cavity where they want to nest. They rely highly on the cavities that are already present in the tree. Once the suitable cavity is formed, they spend about 1 week to 10 days in inspecting the area in terms of whether it's disturbed. Once the mating happens, she immediately enters the cavity. They have very long nesting duration, which ranges about 120 to 140 days. So once the female is inside, she plasters the entrance of the cavity completely, and only one small opening in the form of slit. Mostly the material is her excreta. So once female is inside and sealed inside the nest, the hornbill males are dedicated fathers. So they take care of bringing food for the entire nesting duration. The mother hornbill takes care of the eggs and incubation. Male goes for hunting food, as hornbills eat fruits. And within fruits, figs are their favorites. The hornbills also have a pouch near their neck. It's called gular pouch. So they store fruits in that, and then once male comes to the nest, it regurgitates one by one. If the fruits are smaller, then it can also go up to 400 fruits, which I have counted, and it is just very fascinating. But if the fruit size is larger, then it can go up to 30 fruits. So I was fortunate to observe these birds for more than 500 hours. And once the chick is growing, then the number of visits would go up. And they also feed on animals because to obtain protein content. I observed about 13 different kinds of animal, which included insects, lizards, rodents, and also young birds, snakes, frogs. The nesting begins in around late December and it goes on till end of May or early June. And so every time father comes to the nest, I could very clearly hear chick begging for food. So mother would take it from father and then break it into pieces and give it to the chick. After around 100 days, female comes out. Then there are about 3 weeks, the chick is alone in the nest where it tries to seal the entrance again. And male and female, both hornbills, bring food for the chick. It comes out and lands on a nearest tree or branch or a bush, and then the parents assist it to be around. So for around a week or 10 days, you can see them around the nest itself till it learns how to fly. Then you can't find them. They join the flock. So in flocks, when you go to see the large flocks, wherever they congregate, there you can see a lot of males, multiple females are there. Then you can also make out that there are some young ones because they don't have casques. Then their beak are shorter, not well formed. They are very vulnerable because they have these specific requirements, very specific or specialized habits. There are natural predators like Nilgiri martins, but more than natural predators, it's human threats that hornbills face. First threat is the loss of trees. Then second is the hornbills are also hunted for meat purpose, and some tribes also have traditional rituals where hunting hornbill is considered as a part of their culture. So that is also directly reducing their numbers because many birds are getting killed. But with a lot of conservation initiatives and scientific research, now there seems to be a change in their attitude, and many hunters have become conservationist or nest protectors of these birds. We can definitely try and restore our disturbed forest by planting native trees, hornbill food plants, so that in longer run there will be availability of fruits for them. So my study attempts would definitely try and address some issues, how we could identify critical areas to initiate hornbill conservation, and what could be the best ways in which we could help the species sustain.
That was Pooja Pawar picturizing the beauty and bane of this captivating bird at the Annamalai Hills of Tamil Nadu. From Annamalai, we straightaway shift the scene to the celebrations at the World Arena. April 10th happens to be the celebrations day for homeopathy, the World Homeopathy Day. Professor Shripad Hegde, a homeopath at Bangalore, speaks about the significance of the day.
April 10th is a World Homeopathy Day. Since 1810, where the homeopathy has found and researched and it has given to the suffering humanity to the world by Dr. Christian Friedrich Samuel Hahnemann from Mission in Germany. He started working on that. He did a lot of experiments. India is known as land of homeopathy because in Indian philosophy as well as the understanding of Indians goes very well with the principles and philosophy of homeopathy. The psychological, physical as well as the social health and the spiritual health all together, if it is in a good harmonious way, then only the human being could able to have the good health. The 2022, the World Homeopathy Day, the theme is People's Choice for Wellness. Because it gives a lot of meaning. Now, we have seen and we have experienced during the COVID-19 also, the last 2 years, where the homeopathy has contributed its own way to immune booster in the society to improve their immunity against the COVID infections. I wish each and every person in the world, they should use the system of homeopathy and utilize that, and they could be enjoying their good health. Thank you.
You just heard Professor Shripad Hegde speaking on the significance of World Homeopathy Day. World Autism Awareness Day was recently observed all over. Autism is a band of disorder affecting nervous system, overall cognitive, emotional, social and physical health. Dr. C.P. Ravikumar, practicing neurologist at Bangalore, is with us to speak on autism awareness.
April is the month of autism awareness. Autism is a developmental disability that affects how a person interacts with the people and situations around him or her. It often makes it hard for the person to communicate with or understand the other person. They may also have some behaviors that are different from other people. The cause of autism is not known. There are several theories, but none are conclusively proven. There are certain signs of autism which affects child's development. These can be broadly classified under two categories. First one is social interaction and social communication. Children with autism have trouble relating to other people. They may not be able to read other person's facial expression. They may also have difficulty in making eye contact, or they certainly avoid making eye contact. Sometimes, even though they're playing with other children, they may not actually interacting with them. Children with autism often take much longer than other children to learn to speak. Children with autism show intense interest in certain things, especially spinning objects or shiny objects. They may be preoccupied with a specific topic or a subject. For example, cars. They like rituals. The show must go on exactly as it has happened before. Any small deviation can upset them. They're very good in repeating scripts, meaning if they watch a TV program or a conversation, they'll keep repeating. This is sometimes misinterpreted as child being very bright. Repetitive movements are also noticed in some of them, like flapping of hands, rocking or spinning. Child should be able to share by 9 months, babbling by 12 months, and he should have single words by 16 months, and by the end of 2 years he should have meaningful phrases. If you notice your child is not able to attain any of these milestones, then it is time to seek advice from your doctor. The first point of contact should be your pediatrician who has been looking after your child, or a pediatric neurologist, or a developmental consultant. Unfortunately, there is no single test which will confirm whether your child has autism or not, meaning there is no test that gives you a yes or no answer. Clinicians in the field of autism will conduct assessments by various parameters about your child and also about your family. They will test your child's ability in a lot of ways and make sure the child's symptoms are not caused by a different problem. If your child does have autism, it's important that they are diagnosed as soon as possible. This way, they can get early help and support. The treatment of autism is mainly therapies. There is no tablet or an injection that can fix the issue. And you may wonder what is the most important aspect of therapy. Children will have the best outcome when the families give 100% commitment by their active involvement. And it's a proven fact.
That was Dr. C.P. Ravikumar speaking to us about autism. Artificial intelligence is a fast developing field of technology. We have been witnessing its applications in manufacturing, defense, engineering, medicine, agriculture, and score of other fields. But does it not sound strange that it can be utilized in composition of music and other art forms? Not really. Says Professor Shayan Srinivas Garani of the Department of Electronics, Systems Engineering, Indian Institute of Science, Bangalore. Professor Garani is here to demonstrate the same.
So I'd like to describe how, using Markov chains, we can algorithmically synthesize music. And this is one of the interesting facets where statistical learning and music finds applications together. So what we have done is developed a theoretical framework for representation and automated synthesis of South Indian music based on symbolic dynamics. So this is done by translating the lexicographic rules of a raga to constraints on a Markov chain whose state space is a layered graph. So we analyze the statistical properties of such Markov chains from the point of information theory and learn the statistics and parameters of the model driven by data. For this, we collated a lot of musical compositions from various composers set to that particular raga. We then braided all the notes together, and then we learned the parameters of the underlying Markov chain, and once the engine is ready, then it can beautifully synthesize music. We were also able to generate gamakas artificially. And what musicians think that music is infinite, and in this notion, we were able to say what exactly is the entropy of music. That is, music conveys information through silence and sounds. This is a very interesting side of research. We are also pursuing deep neural network architectures, such as using recurrent neural networks and LSTMs, along with generative transformers to synthesize other musical genre forms, such as Western jazz, etc. This has very interesting applications and opens up a new field of how arts can meet science with a unifying umbrella of mathematics, which explains the underlying science behind the musical art. For example, in the raga Shankara Bharana that we know, right? Sari gama pada ni sa sa ni da pa ma ga re sa. This is how the Arohanam and Avarohanam will go. Tadarin na 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 na. Na, 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 na. So this has a lot of embellishments and gamakas. Of course, it is not easy at a first shot to create all these gamakas together, but we have made an attempt how we can synthesize such notes through mathematical constraints and weave all these notes together in the form of braided notes to form this raga. And here is a snippet of this raga, which is composed by the musician. In this case, the musician is the computer program.
Friends, the journey through the April edition of National Science magazine, Radioscope, draws its curtains here. Hope you enjoyed it. Do write to us and join us again, same time on 13th May 2022 to relish the enchanting glimpses of development in the field of science and technology. Till then, take care. Goodbye.
You were listening to Radioscope, the National Science magazine program, scripted by Shashikant Mummigatti, narrated by Rosalind, Mathew. This program was produced at the studios of All India Radio.